bringing our focus on Python programming paradigms. Do you remember in an early tutorial video, I mentioned to you that programming languages have paradigms bound to them. These paradigms are attributes or features that the programming language supports. Paradigms allow for a programming language to have and support certain features and programming methodologies. As a quick recap, I mentioned that important paradigms of Python programming language are: number one, object-oriented programming; number two, functional programming; number three, procedural programming; number four, multi-paradigm programming; number five, structured programming; number six, event-driven programming. We shall now look at a few of the important paradigms in detail. Before we move on and look at the concept and explanations of these paradigms, I would like to give you perspective of these attributes pertaining to a programming language. You see, in a programming language, when we bring our focus to a specific paradigm, we are not saying that the other paradigms do not exist. We are only bringing our attention to focus on one particular paradigm, and we are only saying that this programming paradigm is the dominant and governing paradigm of the programming language. The governing factor when looking at a programming language paradigm is the explicit and the implicit logic manipulations that this paradigm will mean for the script. We speak about the paradigm relative to the contribution and methodology of other paradigms. Therefore, we seek to explore the ways in which a particular programming paradigm gives the programmer and programming language advantages or benefits. For example, the first Python programming paradigm we will look at is functional programming. We will also look at how the functional paradigm is more beneficial than procedural programming to a programmer. Now, regarding the above statement, we know that Python supports both functional and procedural programming. But when we focus on one paradigm, such as functional programming, we are not completely removing procedural programming from the perspective, but are just reducing its dominance in the perspective of paradigms. Because paradigms are what ultimately decide the behaviors, control flow, and logic of a programming language and its scripts. Therefore, a paradigm will affect how a programmer programs in that programming language. And when we discuss a paradigm, we look at things from two main perspectives. Number one, how the paradigm benefits programmers, and number two, how the paradigm benefits the programming language. Let us begin our discussion. Python programming paradigm, functional programming. An important paradigm of Python is functional programming. Python supports functional programming. The paradigm functional programming is what we have been looking at thus far. Functional programming alludes or refers to a programming language's ability to have a program, irrespective of whether simple or complex, broken down into smaller pieces of logic, functions, that work together to meet a common goal. A programmer is given the ability to make this possible using functions. Functional programming allows a programmer to use functions to solve a problem. Functions, as we have learned, are lines of code that are grouped and execute together when called to achieve a common goal. The main point is that functional programming allows us to break our program down into smaller, logical, more descriptive chunks of code which, when executed, all work together to solve a problem. Python programming paradigm, procedural programming. A very small portion of Python adheres to the procedural programming paradigm. As we know, we have mentioned several times that Python scripts execute from a left to right, top to bottom approach. The way in which this execution occurs, left to right, top to bottom, is a procedure in itself. The procedural programming paradigm allows a programming language to be governed by procedures. Procedures are elements such as our decision-making structures, if, else, alif, and loops, for, in, while. meaning that all logic is placed in a single script with no boundaries or enclosures, functions that separate the different pieces of program logic to a great extent. The program will execute from left to right, top to bottom, in the sequence in which the procedures, code statements, occur in the script. Python is a versatile language. It supports both functional and procedural programming paradigms. Therefore, one may find it a bit difficult to understand two different paradigms in a language that supports both. Therefore, we shall look at the two paradigms using two separate programming languages as examples. We shall now gain more insight into the two paradigms, functional and procedural programming. I will present the information to you in a tabular format which will convey the main points as well as highlight differences between functional and procedural programming language. We will thereafter have a short discussion for more insight into the concepts. Functional programming, procedural programming. Functional programming. A programming language that is functional in nature is often said to make use of expressions. Procedural programming. A programming language that is procedural in nature is often said to make use of statements. Functional programming. Expressions have values assigned to them. A functional program is an expression whose value is a set of instructions that the computer needs to follow. Procedural programming. Statements don't have values. Instead, they modify the state of your machine internally. Functional programming. In a purely functional programming language, such as Haskell, there would absolutely be no statements. Procedural programming. In a purely procedural programming language, such as machine code or binary, there would be no expressions. Every line of code would be a statement instruction that will manipulate the state in which your machine is in. The previous slide mentions the core differences between a functional and procedural programming language. This is why I mentioned that it is a bit difficult to understand the two paradigms from the perspective of a programming language that supports both. Machine code binary is a programming language spoken by our CPU. Machine code is an example of a purely procedural programming language. We understand that procedural programming makes use of only statements which execute line by line one after the other, and they directly modify the state of our machine. There are only statements in procedural programming and no expressions. Haskell is an example of a purely functional programming language. We understand that functional programming makes use of only expressions, which are the functions in the program that hold a sequence, several lines of instructions for the computer to follow. Procedural programming focuses on blatantly listing steps to accomplish the task at hand. Procedural programming addresses how the program should go about solving a problem. Functional programming focuses on program logic. It aims to define the problem and identify an appropriate solution. Functional programming addresses what the program needs to do and accomplish. So, we have understood the separate concepts of procedural and functional programming. Now, let us put it into perspective of Python. Remember, these concepts belong to advanced Python, and even experienced developers agree to the following. The confusing part is that the vast majority of programming languages contain both expressions and statements, allowing you to mix paradigms. Languages can be classified as more functional or more procedural based on how much they encourage the use of statements versus expressions. OmniMic. Let us put the two paradigms in perspective of Python. I have created a simple diagram which shows how the structure of a Python script changes in the functional and procedural programming with Python. Functional programming. Script logic chunked and broken down. Order of execution is dependent on function calls and is not 100% known. Procedural programming. All lines of code execute in order it is encountered. Simple example of the paradigms. A simple example of the functional and procedural paradigms in Python can be illustrated by the following script, one in which the ingredients of a cake are printed to the screen. Looking at the previous slide, notice how all our code are simply instructions, statements that will be executed one at a time. Procedural programming. Functional programming would be done as follows. Looking at the above image, we see that functional programming makes use of expressions, functions, which hold values. The values are series of instructions for the computer to execute. I would like to apologize if there is a lot of redundant or repetitive information in this tutorial. My goal is to ensure that I give you all important information about these programming concepts and to make sure that you understand to the best you can. I should mention though that we are doing well in our endeavor to learn about Python programming paradigms. For the next portion, we will cover a few interesting points which explain the advantages and disadvantages of functional programming methodology. Functional programming, advantages and disadvantages. Advantages. Number one, less code. It is typical for functional programs to require less code than an equivalent procedural program. Number two, reusable code. Functional programming allows us to reuse expressions, functions as many times as we would like after creation. If you remember, we are able to do this by calling our function as many times as we like after creation. Number three, no or reduced hidden side effects. We will speak about this a bit later. It is important and interesting, and we will look at this with an example in Python, a concept called referential transparency. Number 4. Suitable for prototyping, developing early solutions. Functional programming allows for initial solutions to be created and tested in a short space of time and with ease. Disadvantages. Input-output flow. The flow of input and output in a functional programming language is more difficult to handle. Number 2. Interactive applications. It is much more difficult to design and create applications that are interactive with a functional programming language. Number 3. Endlessly running programs. Setting up a continuous loop can be a little bit more difficult with a functional programming language. Number 4. Programmers are less familiar. Yes, this is actually a disadvantage of functional programming. The level of difficulty of functional programming is a bit on the high end of the scale. Therefore, I provided relatively lengthy explanations about the main concepts because, as we know, when we understand the logic behind a certain concept, it automatically becomes easier to digest and we feel more comfortable being around it. And since we are setting a good foundation of the paradigms, when we code our practical examples, we will be comfortable with object-oriented programming, functional programming, procedural programming, and any other paradigm we may encounter. A short note on procedural and functional programming. Well done. We have just covered the most important information pertaining to the functional and procedural programming paradigms in Python. Now, we shall continue looking at functions in Python, and after obtaining more insight into functions, we will revisit the paradigms above again briefly. A bit earlier in the tutorial, we looked at the way in which a function is created in Python using the def keyword, def or define. Now, we shall move on from there and explore more features of functions in Python. Types of functions in Python. You see, in Python, there are overall two types of functions that exist. We get built-in functions, as we have covered in a previous tutorial, and we get user-defined functions. Built-in functions are functions that are built into Python. These were built into Python by the Python developers. We have seen several of these functions up to this point, examples being the print function and the input function. All built-in functions are provided by Python. On the contrary, user-defined functions are those functions that are written by us, programmers or software developers. Returning values from functions. As you know, we have created and looked at functions in Python with and without parameters. Now, oftentimes we may need to return a value from a function. This means that our function will return a value to the main program, which can be processed further. When a function returns output to the main program, we are allowed to store the returned output in a variable. For example, we will define a simple squaring function in Python which will have one parameter x and will return the square of the value passed to it as an argument. The result is a simple two-liner function. Define square parameter x, return x to the power 2. Pay careful attention to the return keyword that we see. According to our code syntax, the square function will return to us x to the power 2, which is x squared. Now, a function that has the return keyword in it tells us that the function, is going to return a useful output to us, which we can store in a variable and use in our main program. The way in which we call a function is dependent on whether or not a function returns a value to the main program. Let us call our square function and pass in 2 as an argument. Looking at the image of the output console on the previous slide, we see that there was no output given by our program even though we called the function. Ideally, what should have happened is that our program should have outputted the value 4 because 2 squared is 4. But instead, we see no output, yet the program did indeed run successfully. You see, because our square function returned an output to the main program, we need to store this contents in a variable and then print the contents of the variable to the screen. So we would attempt to modify the code of our script as follows. Define square x, return x to the power 2, that remains the same. Notice we now have a variable, 2 squared is equal to square 2, print 2 squared. Our square function is returning a value to the main program. Looking at the previous slide, see, we assigned that specific call of the square function with the argument 2 to a variable named 2 squared. This variable is needed because the square function returns an output. There is a piece of information that is being outputted from this function, and to hold on to that information, we need to store it in a variable. And to access that information, we need to print that variable to the screen. Output will be seen as follows. 4. Another way to view the output of a function that returns a value would be to directly print that instance of the function call to the screen. Define square x, return x to the power 2, print square 2. Notice how on the previous slide we did not store the contents outputted by the function in a variable. We simply printed the function call to the screen and we are returned with the following output, 4. The reason as to why we receive output when we do this, print square 2, and not this square 2, is because the print function is printing our output to the screen. In the square function, a value is returned to us which gets printed by the print function. By simply calling a function that returns a value, we will not obtain the value as there is no feature to store it or direct it to our output screen. Logically speaking, the value or output of that function is lost or floating around somewhere in RAM. To help you understand even better, do you remember in the beginning of this tutorial, we coded a simple function that went like this. Define addition function num1 num2, print the sum of num1 and num2 is num1 plus num2. Now you see, the function we coded in the above image is not returning any value to the main program, which is why we called it like addition function 55. There was no need to store the contents of the addition function in a variable and then print it to the screen because the addition function, logically speaking, is not returning any value to the main program. To confirm this fact, we can try printing the particular instance of addition function to the screen. Print addition function 55. The above line of code will show output as follows. Looking at the output shown on the previous slide, you will see that we get the calculation statement done by the function and then we get the word none. This is interesting because this confirms to us that the print function was given nothing to print to the screen. When functions and parentheses are involved in Python, the statements will execute from inside out. So essentially, first the function was executed inside the print statement and then the print statement was executed. And the print statement was not given anything to print because the addition function did not return any value to the main program, in this case the print statement, to process or execute. I do hope that this makes sense. One very important point to mention about the return keyword. When the return keyword is encountered inside a function, then that function will terminate and all lines of code after the return keyword will not execute. For example, define hello world, return hello world. Print everything after print the return keyword print will not execute. Print hello world. Before we look at output, let us discuss logic. On the previous slide, we see that a function has been created by the name of hello world. This function does not require any arguments. We see that the return statement has been used in this function. This function is said to return the words hello world. We also see that there are lines of code that appear below the return statement. But from what we have discussed, a function terminates upon encountering a return statement. And therefore, we know that we would not see any lines of code after the return statement being executed. We see that we have chosen to print this particular call of our function to the screen. Since statements occur from innermost to outermost, we expect the hello world function to execute first, which will return hello world back to the main program, and then enclosing the output returned by the hello world function is a print function. Therefore, we can expect to see the output hello world in our IPython console. Output shows as follows. Hello world. Our logical inference of the task at hand are met, and we see output as we have expected. Types of function configurations in Python based on arguments and return values. Based on what we have learned thus far about parameters, arguments, and the returning of values, it is good to know that there are 4 different function configurations that we can have in Python. This means that you will have the ability to code functions with the following configurations in Python. These are: number 1, no argument, no return value. Number 2, no argument, return value. Number 3, argument, no return value. Number 4, argument, return value. For a better understanding of the different function configurations in Python, we can code an example of each. Number 1, a function with no argument and no return value. Define addition function, x is equal to 10, y is equal to 10, print x plus y addition function. Number 2, function with no argument and a return value. Define multiplication function, x is equal to 10, y is equal to 10, return x multiplied by y, print multiplication function. Number 3, a function with argument or s and no return value. Define subtraction function, x, y, print x minus y, subtraction function 100, 10. Output to the four functions we have created will show as follows: 20, 100, 90, 2.0. Returning multiple values from functions. Functions do not limit us to returning only one value. For example, we are able to return more than one value. The logic is shown in this simple swap function that we have coded. Define swap xy, return yx, print swap 5, 10. The output to the previous slide will show as follows. We get a tuple in which the input values reside with their order swapped, 10, 5. Functional programming, referential transparency. RT, referential transparency, is a very important concept in the world of functional programming. If you remember, we mentioned a bit earlier in this tutorial as one of the advantages of functional programming. There is no or reduced side effects in functional programming. Now you see, what enables us to have reduced side effects in functional programming is the principle of referential transparency. You see, apart from the differences that we have discussed between functional programming and procedural programming, there is one more that is very important. Functional programming makes use of functions. Procedural programming makes use of procedures. The difference between a function and a procedure is that a function will be referentially transparent, RT. This RT means that the function will always return the same result, output, for the same value, input. To give you a simple example of a function being referentially transparent, take a look at the next slide. X is equal to 25, y is equal to 25. Define sum of 50, x, y. Return x plus y. Print sum of 50. When called a few times, we observe output to the function as follows. The image of the code that we see on the previous slide depicts a function. We know it is a function because it is referentially transparent. We know this because we called the function multiple times and the output it provided to us was the same each time. There were no side effects that caused the function to give us a different output upon each call. It remained consistent in the output that was shown to us. Now, we shall expand on the concept of functions and procedures. Let us take a moment to look at the example that is shown over the next few slides. Functional programming. Count is equal to 0. Define function to add 1. Count. Count is equal to count plus 1. Return count. Output to the previous function will show as follows. 1, 1, 1, 1, 1. Therefore, from the above image, based on the output we have seen, we are able to confidently conclude that we are working with a function. We are seeing the functional programming paradigm at work in this particular block of code because referential transparency is visible. Now, view the below block of code. Procedural programming. Count is equal to 0. Define procedure to add 1. Global count. Count is equal to count plus 1. Return count. Notice that in the block of code shown in the previous slide, we see the global keyword being used next to the variable named count. This tells us that count is a global variable which is accessible and able to be modified from anywhere in the Python script. One way to tell the difference between functions and procedures is that procedures tend to make use of the global keyword. Thus, each time we increment the count variable by 1, the value of the count variable is updated and propagated throughout the program. To increase your level of understanding, take a look at the output we obtain from this function. 1, 2, 3, 4, 5. Looking at the previous slide, we are able to see that this block of code has returned to us a different output each instance it was called. This is the point at which we are able to conclude that we are working with a procedure, not a function. This block of code confirms that we are seeing the procedural programming paradigm in action in this Python script. There is no referential transparency. Output is not consistent. I do hope that these explanations make sense. And with that, we have successfully learnt about two important Python paradigms, namely the functional programming paradigm and the procedural programming paradigm. Conclusion. I think that we will end this PowerPoint tutorial here. As a side note and for information purposes, this tutorial was 95 slides in duration. Thank you for taking the time to read and watch till the end of the tutorial, and I do hope that you have had valuable takeaways from this presentation. Our next tutorial will look at the object-oriented programming paradigm in Python. Thank you for your time.